All right, here is a question from the textbook that says, complete the following table for neutral atoms of specific isotopes. Okay, remember an isotope is or isotopes are atoms of the same element, but they have a different mass. Okay, and the mass comes from the number of protons and neutrons together. Okay, so the key here is that these are neutral atoms, which means there's no net charge, which means the number of protons is always going to be equal to the number of electrons. Okay. Of course, the number of protons is equal to the atomic number, so that will help us to fill out, this column here, the atomic number. So atomic number 27, that's equal to the number of protons. So I can put that in there. And that for a neutral atom is equal to the number of electrons as well. Okay. Now, here it's saying the mass number is 60. The mass number is the sum of protons, the number of the atomic number, the number of protons plus the number of neutrons is 60. So that means I must have 33 neutrons, because 33 plus 27 equals 60. Okay. Then the only thing left here for this one is the isotopic symbol. And for that, in order to know what element it is, we look at its atomic number, the number of protons, and element number 27. If we look at a periodic table, we see that is cobalt. All right, element number 27. And so we're going to write this as cobalt 60, okay? Or just like they have here, we put the 60 in front and the cobalt like that. All right, so let's go ahead and work out this top one. Let's see here. All right, fine. I may need more space, so I might have to spread these out a little bit. So xenon 134. You look at the periodic table. Here's xenon. Its atomic number is 54. Okay, so there we can put that in there, 54. The mass number is, again, the number of protons. All right, so there's our three columns. We can go ahead and fill those out. The number of protons is equal to the atomic number, and in a neutral atom, that equals the number of electrons. Right? The mass number is the sum of the protons and the neutrons, and that is given here. You notice we did that with the cobalt. This is the mass number, okay? Not to be confused with the atomic mass, which we see here, okay? That's the average atomic mass of all the isotopes in their natural abundances. But here's one specific isotope, xenon 134, okay? And it has a mass number of 134. That's what that number represents. Okay, and then so the number of neutrons is the difference between 54 and 134, which is going to be 80. Okay, so let's go on here. We have letter C. Okay, what we're given is the number of neutrons and its mass number. Okay, so the mass number, again, sum of protons and neutrons. And so if we subtract the neutrons from the mass number, we'll get the number of protons. So 144 minus 84 will give us 60. Okay, and then the number of protons is equal to the atomic number. It's the same thing there, 60. And then the number of electrons in a neutral atom will equal the number of protons. So that will also be 60. So here we have atomic number 60. So that's what's going to determine the element that we have. And this one we see, where did it go? It is, okay, I'm on the wrong page. There we go. Element 60 is neodymium. It's actually one of the elements in certain strong magnets. But anyway, element 60, so Nd, and then the mass number is 144. So here we're going to write 144 Nd. Okay, neodymium 144 is how we would read that. Okay, so now let's go on, and we have atomic number 22. Right, that is the number of protons, and in a neutral atom, that's equal to the number of electrons. Okay, so 22 electrons, and we have 26 neutrons. I said electrons, but I meant protons. Okay, we have 22 protons, 26 neutrons. So the mass number is 22 plus 26, which is 48. Okay, so element 22 is titanium, and it has a mass number of 48. So we're going to write that as 48 Ti. Okay, titanium 48. All right. Now we have here the number of neutrons and the number of electrons. All right, but again, we're considering neutral atoms of the of each isotope. And so if this is a neutral atom, then the number of electrons equals the number of protons. Okay, so that will be 72 protons. And if we have 72 protons and 106 neutrons, then we have a mass number of 178. Okay. And the atomic number is equal to the number of protons. So that's 72. And if we look at element number 72, with a mass number of 178, that's going to be hafnium, and we put its, let me get this resituated here. Where did I, oh, my transparency is a little shifted there. All right, so this is going to be hafnium 178. We write it like this, 178 HF. Okay, and let's see, we've got a couple more here. Here we are given the mass number and the number of protons. Okay, so the mass number is the sum of protons and neutrons. We subtract the protons from the mass number, and we will get 74. Okay, and so the number of protons in a neutral atom is equal to the number of electrons, and also the atomic number is equal to the number of protons. Okay, so we're looking at element 52 with a mass of 126, and that is going to be tellurium, Te, so Te 156. All right, 156 Te. All right, one more line remaining, and this one we have 16 protons and 18 neutrons. So we add those together to get the mass number. 16 plus 18 is going to be 34. If we have 16 protons in a neutral atom, we're going to have 16 electrons. And the atomic number is also the number of protons. So this is element 16 with a mass number of 34. And that is going to be sulfur 34. Okay, so we're going to write that as 34 sulfur. Okay.